All right, so we're going to go through a parallel circuit now. And what we've got here is our battery positive, battery negative, and we just stack these. We could use any of these terminals. They're all power and ground, but we just stacked them to show you basically how splices work in the wire harness. They're spliced together on the ground, they're spliced together on the power side. And to test this, we're just simply checking source voltage. So again, what is the source voltage? Well, it's 13.76 volts. In a parallel circuit, the voltage, the total voltage is going to be the same as voltage 1. So voltage 1, 13.75. Voltage 2, 13.69, roughly the same. And 13.71 volts. So voltage stays the same. So that means total voltage equals voltage 1 equals voltage 2 equals voltage 3. Very similar to our series where the amp stayed the same, voltage stays the same. Current. Now we're going to talk about current for a minute, which is amps. So we're going to move it to amps here, and we're going to move this back again here like this, and we will do a total amperage. So we're going to go remove the circuit here, and we're going to test how many amps is the total amps. So we simply touch these here, there to there, and we are 293 milliamps. Okay? So remember that number. Next, what we're going to do is we're going to measure each of these individual circuit amps. So we're going to go off this bottom one here and 0.098. Okay. We're now going to swap this one out and measure the second one right here. 0.095. And the very last one, remove this one here, 0.098. So what did we find here? They're just under 1. And if we go back here to our original, we're 0.298 roughly, okay, 0.294. So in a parallel circuit, amp 1 plus amp 2 plus amp 3 gives us the total amperage. Okay, so they're going to add up. Amp 1 plus amp 2 plus amp 3. All right, which brings us to ohms. So now we're going to move this to ohms, resistance, and we're going to move this one now back to our volt ohm piece here, and we put it on ohms. All right. We're going to disconnect this circuit right here, all of these, and we're going to measure total resistance. Okay, I want you to pay attention to this for a minute. The resistance is 4.3 3 ohms total resistance. Removing this first one, we put this across here, and we have 13.2 ohms. Again, 13.2, and now if I measure across here, 4.4, this is smaller than 10. So, the total resistance is always smaller than the smallest resistor. Okay, there's a formula that you can use to figure this out, mathematical formula that we'll teach you guys. But the smallest resistor, whatever one of these is, for example, 5 ohms, we'll say this one's 5 ohms of resistance, it's going to be smaller than 5 ohms. If it's 3 ohms of resistance, it's going to be smaller than 3 ohms of resistance for the total resistance. The total resistance is always smaller in value than the smallest resistor. So whatever the smallest resistor is, know that the total will always be less than that.